Hey, what's up everybody? Welcome back to another layer by layer tutorial. In today's tutorial, we're going to learn how to inspect parts in Eagle CAD. So we're going to be doing a new series of Eagle CAD tutorials. And this is really cool for any makers who have used breakout boards, maybe interested in designing PCBs. This is great for makers who want to take their designs and turn them into kind of PCBs that are ready more easier. You don't have to do a lot of wiring, for example. You want to take your design off the breadboard and get it into a actual PCB. This will save you a lot of time, especially if you want to manufacture your product or something, your breakout board. This is a great way to do it. This is also great for designers who want to make artistic like art badges with using LEDs. So here's a really simple circuit, has a beautiful silk screen, and it's relatively easy. So this is really good for that as well. So what we're going to do is we're going to look at Lamar's JoyBonnet for the Raspberry Pi, and we're going to download this and take apart the schematic and take a look at the board file itself. So all of Lamar's boards and Adafruit boards are open source and you can download them. If you go to the learning guide and in the download section, you can grab the Eagle CAD file here. It's free to download off of GitHub. Here's what it looks like in GitHub. You just click on this green button, the download button, and then download the zip so that you can have the board file and the schematic file. All right, so once you do that, you do want to have a downloaded Eagle. It is a free version of Eagle CAD. It's pretty nice now. It's for Windows, Mac, and Linux. You get a board area of 80 centimeters, so you can make a fairly large board. It used to be smaller than that, and there's a lot of cool new features in Eagle CAD, so definitely recommend it. If you have an Autodesk account already, then you can already download it. Just sign in and download it away. All right, so once you download the zip file, you'll get the board and the schematic file. These are all Eagle CAD files, and they can totally open in the new version of Eagle, which happens to be 8.3.2. So here it is. I just opened it. There's a control panel here, which has a lot of different things like documents and libraries and that sort of thing. But we're going to focus on this guy here. So you can double click on this to expand it. One of the cool new features. All right, so let's talk about just navigating your part or your board file. To zoom in, it is the scroll wheel. To zoom out is also the scroll wheel. Zoom in, zoom out. And to pan your board is you click on the middle mouse button, and then you click and drag to pan around. So that's really how you navigate inside a board is those two things, is panning with the middle mouse button and scrolling with the mouse scroll wheel. So that's how you kind of move around in here. All right, the next thing I want to show you is when you zoom in, you can actually see what these traces are because they have labels in them now. So you can see that this is the ground connection and it's connecting to all the buttons. This is the joystick. The joystick has a ground connection here. Same thing with the pad. These little green guys here, these little green oblong and circles, those are the pads. So if you look at this next to the actual product, this guy here, you can kind of make it out already just by looking at this physical photo and then looking at this. You can clearly see these two are buttons. These are two bigger buttons. There's a chip right here. There's a joystick, and there's 4 action buttons. This blue thing here is actually the header. So if you go to the back here, there is the Raspberry Pi header over here. It's the female header. And this tells you all of the connections as well. So you can see all the GPIOs. You can see exactly which buttons are connecting to which pinout. So you can see the A, you can follow the trace and see that it is actually connecting to Gpio 32. So that's really cool. So that's a good way of knowing just where things are. The next thing I'm going to show you is how to inspect parts. So there's a wide assortment of tools here in the sidebar, but most of the tools can actually be accessible through a contextual menu. So let's say I wanted to inspect this button here. You'll notice that the button has a crosshair. It's a white crosshair here. It's pretty thin, and you'll notice that most of the buttons have that. Even this chip here, this audio to digital converter, also has that, and you'll notice that the joystick has it too. If you look carefully and zoom in all the way, you can actually get that. So when I right click on it, you actually have the contextual menu will give you lots of different tools that are relative to that object. You can copy it, move it, all that sort of stuff. And properties will actually give me a new window and tell me exactly where this object or this element is relative to the canvas center point. So you see that it says position 045 and 059. So this is the X axis and this is the Y axis. This happens to be at an angle of 90 degrees. It tells you what part of the library it is and then the package name. So this is the micro builder library. That is the library that Adafruit uses, and a couple other of inspected elements. So we can hit cancel now, and you can do that to just about anything as long as you use that crosshair. Sometimes it works outside of it. Other times it won't work. As you can see, it only works once you get near that that crosshair. So I can inspect it. This is a EVQ Q2 smaller button. That's what's just the name of it. Hit cancel on that, and you can also inspect traces as well. So you can inspect a trace. You can see how wide it is, what layer it's on. Currently it's at the top layer. Most of the traces are just on the bottom and the top layers. So the top layer is red, and these blue ones are the bottom layer. So it's on the bottom of the board. So you can see that where it is, again, what the width is. Next thing I want to talk about is the grid. Currently there isn't a grid here. To turn that on, it is up here. There's a grid icon. You can click on that. It gives you a little window. You can change the display of the grid. You can display inches here. Let's say I want to do 1/2 inch. Hit OK, and you can get these little grid points here. Let's say I wanted to use not inches but millimeters. You can do that too. You can switch to millimeters. Maybe put 0.5 of a millimeter. And now when you inspect an object, it'll tell you where it is in the position in millimeters. So I right click on it on this joystick, hit properties, and it'll tell me it is 11.43 millimeters on the X and 14.986 millimeters on the Y. So let's talk about where the center origin of the whole document is. It's actually right here. This dotted crosshair is 0, 0. So that's the position 0, 0. So the way it works is that anything to the right of this crosshair is a positive value. Anything to the left of this is a negative value. Anything going up is a positive value on the Y, and going down is a negative value. So you'll notice that most of our rectangular boards have this center origin 0, 0 to the lower left corner of the board. You'll notice things like Circuit Playground and Gemma are actually centered around that crosshair, so they have some negative values here. So just keep that in mind, that's kind of how it works. You notice that's kind of how it works for these buttons as well. You notice that the crosshair isn't actually on the corner, it is actually centered to it, and that just makes it a little bit easier for these type of elements when they have a center crosshair. So that's how that works. Next thing I want to talk about is the schematic, right? So up here, there is a button that can let you switch between the board and the schematic. So I'm going to click on that, and that'll show me the schematic. So the schematic has all the symbols that make up the circuit. Let's look at this guy here. This is the Raspberry Pi Gpio header. So you can see that there is 40 pins, 20 on this side and 20 on that side. And they all go from 1 to 2, going left to right, and top to bottom. And then they all have labels. So you can see that pin 1 is 3.3 volts. And pin 3 is the serial data, serial clock, Gpio pin number 4. Now take a notice that the Gpios are actually, the number of the Gpio is different than the pin number. That's just sort of the way that it is by design. So that's what this red thing here is. These green things are actually just labels, or just wires that have labels to these pins. So that's how you're able to get these pins here. So we can inspect them as well. You can right click on it and look at the property and just see it's a wire and that it has a name. So each one of these, you'll notice that the 3 volt pin number 1 is also tied to pin number 17, which happens to also be the 3.3 volt pin. You notice that it's also the same for all the ground connections. They all have these wires that kind of come out and connect to each other. So that's just one way of routing all these grounds together so they don't have individual grounds. And this is a ground symbol. This is just a symbol that that indicates that it is a ground element, inside a symbol inside of the schematic. So you look on this side, we also have some grounds connecting on that side, and we have a symbol for the 5 volts as well. This is a symbol that's a part of the supply 1 library. Okay, next part over here, you'll notice that this is a ADC. This is a audio to digital converter that's used to convert the analog joystick into digital. So you can see here that it has a couple of pins here. These are analog inputs, and these are serial clock and serial data pins. It tells you what pins they are. This is where the voltage comes in, and this is where the ground comes out. And over here, it has a label for analog pin 0 and analog pin 1. These inputs are actually going to Joy horizontal and Joy vertical. So these are actually the connections going to the X and the Y axes on the joystick. And the joystick itself is over here. This is the joystick. It has 2 potentiometers. That's what they look like. And they have labels here that tell you where they are. So you got the X-axis and you got the Y-axis here. And you can see that they both have 3 connections. They have a ground, a signal, and a voltage. And they both have that there going on. Over here, the last kind of group in the symbols of the schematic are just switches. If you know what switches look like in schematic land, they look like this. These particular buttons have 4 legs, so that's why there's kind of these 4 lines here. This is representing kind of a button, and the dotted lines represent that when you get pushed, this little guy here closes the circuit and creates a switch, right? So they all have the legs over here all connecting downwards to a common ground. So you can see the ground symbol. And then all the other legs here, the adjacent legs, all have signals that are connecting to the 2 legs. And they're all connecting to their respective kind of signals. So you got select buttons, start select, player 1, player 2, A, B, X, and Y. And again, if you wanted to inspect them and find out what part of the library they are, you can see that as well. So that is how the schematic works. That's how it works. You mainly create this first, and then you work on the board and route it. So let's switch back over to the board, and let's take a look at maybe reusing some of these components in a new design. Let's say we wanted to make a bigger version of this JoyBonnet and make it like bigger with the bigger buttons and more space for your hands. You could totally do that and reuse some of these components. It would definitely be a lot trickier to have to remake and relabel all these things. So it's really nice to know how to kind of get these parts out of this design and into your own library if you don't have access to the library, that is. So let's go ahead and right click on this joystick. Let's say we want to use that in our new design. You can click on here and say open device or open package. Any of these 2 will work. Let's say we want to open the package, and the problem is I currently don't have the micro builder library. You could of course get it from GitHub, but for this tutorial I want to show you guys how to access library parts without having access to the library. So I'm going to hit OK. I'm going to zoom out a little bit, and there's this button up here that lets you execute scripts. These are ULPs. So I'm going to click on that, and it brings me up to this folder here. This is located under the Eagle CAD folder under ULP. There's a wide assortment of different executable scripts that are built into Eagle that you can choose from. There's one that actually exports parts libraries from a given board file. And what you want to do is you actually want to do this in the schematic and not in the board, because you won't get all the parts. So let me switch over to the schematic and then click on the ULP button and then scroll down to EX library, I believe it's called. This guy, exp-lbrs.ulp. That's the file. And again, it is a file that comes with Eagle. Your installation of Eagle comes with this. So I'm going to go ahead and open, and it's going to tell me where do you want to save the parts. And that's fine. That's where I have it. And this is going to tell me I want this option to merge all the parts into one library. I want the symbols unchanged along with the packages and the device name. So I'm going to hit OK. That's going to run through the script and basically steal all of the symbols and parts and objects that are a part of the part of the JoyBonnet board and schematic. So what I'm left with is this library editor mode. I'm going to click on this button over here. This is basically, this whole panel is like the library editor. So this is where you can edit parts, edit symbols, that sort of thing. So I'm going to click on this button over here called Table of Contents. And this will show me all of the parts and devices and packages that were exported from our JoyBonnet. So you can see here that devices are basically groups of packages, and symbols are what are tied and connected to these packages. So let's take a look at the joystick, and then over here under package, or let's just, click on the joystick, and we're going to edit that. So right click edit, and we'll get this here view. So you can see here this main canvas area shows our two potentiometers in symbol mode. So there are all these symbols. You have these tools here that allows you to add symbols to this area. And over here is the kind of footprint, the visual footprint with pads and mounting holes that represent our part's footprint. So if you wanted to find out how these pads are connected to these symbols, you basically have it in this area here. So if we click on the connect button, you can see that our pins are connected to these pads. So that's how they are set up. So hit cancel on that. Let's say you wanted to just modify this area here, this guy here. If you want to modify the footprint for this guy, you can come in here under the package and then grab that package here, the joystick analog, hit OK. And now we can see the joystick itself and kind of inspect it. So you can see these pads here. There is actually a pad object. It's kind of a tool, and you can kind of switch between different types of pads, that sort of thing. That different diameters of the pads, different drilling holes. You can see this one's a little bit bigger than the one that is used in the design. And of course, you can right-click on them and inspect them and see where they are relative to the design. You can see here that they are negative 78 millimeters on the X, and then 340 millimeters on the Y. I believe that's not millimeters. It's probably something else. Yeah, that's mils. So we want to change this to millimeters. Maybe we change this to 0.5 of a millimeter and leave our display on for the grid. Hit OK. And now when I right click on in properties, one of the pads, you can see that they have round numbers. So -2 and 9 again. This crosshair, this tiny little crosshair here in the center of the design, is basically 0, 0. So if I were to right click on this and change this to 0, 0, this should be in the dab center. So this is in the dead center of that because it's 0, 0. We can undo that with Control Z, and then I can go look at it again, and you can see this is the X axis and this is the Y axis. So if I wanted to go +2, you'll see that it goes that way. Obviously it went that way over here because this is +2. So it kind of overlapped it. And you can see it's at an angle at 90 degrees. You can see the drill diameter. You can change the shape if you wanted to as well. I don't know why you would want to do that, but you could do that if you wanted to. So that's really cool. And these guys over here are mounting holes. You can see how big the mounting holes are. It's got a drill side of 1.6 millimeters. And this is really cool. These crosshairs here and this kind of shape here is all kind of things that can show up in your silk screen. So let's take a look at the actual device here. This is the actual device, the part. You can see that it has kind of crosshairs going on there, and it's got this kind of metal casing, and then on the bottom of it has this plastic casing. You can make out these little kind of plastic studs, these little studs here. So to have these mounting holes in your PCB will actually give it much more mechanical strength and stability. So that's really clever that that's in there. And of course, there is a diagram. So you can right click, view, and see the diagram that Lamar used to draw this. So you can see all the numbers here are pretty much matched up with all this here. All these pads and whatnot have the correct dimensions. So that's kind of how it was designed. And then you can see her breakout board for this mini thumbstick. it actually shows up fairly well. You got the mounting holes there, and you got the 3 pads on each side for the 2 potentiometers, and you have that nice kind of footprint going on. So this is a really nice way to kind of show you how the physical PCB looks like and how the digital version of it in EagleCAD looks like. So that's really cool. You can of course do this to other things as well. You're not just limited to the joystick. Let's say you wanted to look at maybe making a kind of your own JoyBonnet. Well, we have a JoyBonnet part here. You can see that this has the 40 pin connector, and it has the board size, the board cutout, and the mounting holes in the right spot. So if you want to make your own Raspberry Pi Zero type board, you could do that. We also have one for, I believe, the regular Raspberry Pi, like the Pi Hat. Like this one here has like a nice slot in here for the whatever connector. You got the mounting holes, and you got this kind of cutout here for, I believe, the SD card. And of course, everything is in the right spot. So you can use these parts in your design. And I think there's a couple other ones here. Raspberry Pi, I believe, shields. If you wanted to make a shield for the Raspberry Pi, this has kind of all the pinouts for you in the right. Again, the mounting holes are in the right spot. So you can use all these. And this is what Lamar uses to make her designs. It's really smart to reuse these packages and stuff. So going back to the table of contents, this is where all the stuff resides in. And let's take a look at the joystick again. I think we kind of already did with like looking at the symbols and stuff. So you kind of know how those are connected. This is more of a crash course on how you can inspect parts and kind of start getting your feet wet on understanding boards and stuff like that in EagleCAD. So I know it's a lot to digest and there's still a lot to it, but I think this is a good introductory and a good ending point to kind of showcase how you can reuse these parts, how you can inspect them, and what it all means here in EagleCAD. So let me know what you guys think. You can download Eagle, obviously, using the download links below and playing around with it. Let me know what you guys think of the tutorial, and again, I have some future ones coming up. I'll have probably a playlist or something so you guys can check it out. I'll see you guys in the next one.